Now that we know how to solve polynomials that are in factored form, we're going to work on using the area model in order to remove the greatest common factor and get our polynomial into factored form. So let's start by looking at number 6. Let's make this bigger. We're going to need some room. And let's use number 6 and do an area model to factor it. So we got 3x and we got 24x squared. So I need to come up with something I can divide out of both of these. So when I'm looking at it, I can see that I can take out a 3, because I could divide a 3 out of this very first one, and I could divide a 3 out of this, so that works. I look at it again though, and I also see that I've got an x in both of these, so I can divide out a 3x from both of these. So let me go ahead and complete my area model. So 3x divided by 3x is 1, and 24x squared divided by 3x. 24 divided by 3 is 8. X squared divided by x is 2 minus 1 is just plain old x. Okay, so my factored form is 3x times 1 plus 8x. All right, so what if we are doing our area model for a factored form and we don't see all the factor that needs to come out? Let's see what would happen if we did that. Okay, so on number 7, I want to take out my greatest common factor, so I'm going to use my area model, and I've got 12x cubed and 18x squared. Okay, so when I'm looking at this, I can see that I could take out, looks like a 6x. Okay, so let's divide this out. 12x to the third divided by 6x. We got 12 divided by 6 is 2. X to the third divided by x. 3 minus 1 is 2, so 2x squared. And then again, I got 18x squared divided by 6x. 18 divided by 6 is 3. X squared divided by x. So 2 minus 1 is 1, so just 3x. Okay, am I done? Well, the way I find out if I've truly gotten out my greatest common factor is I look at my two factors. To know if this is the greatest common factor, I look at what's left. When I look at this, could I put this in an area model and take out anything else? Well, now that I've got it down like this, I can look and see, you know what, I still have an x in both of these. My number looks okay, but I still have an x. So I need to redo this, removing not just one x, but remove two x's, so x squared. So I'm just going to redo my whole area model. So I'm going to do 12x to the third, 18x squared. But this time I know I need to take out not just 6x, but I need to take out 6x squared. And when I take out 6x squared, that leaves me 2x and 3. So my answer is 6x squared times 2x plus 3. So that's my answer. So area models work out great. You just have to, if we're looking for the greatest common factor, sometimes you have to take it in 2 or 3 steps before you've seen everything that you can take out. All right, so I want you to do number 8 on your own. So pause your video, do number 8, and then check back for the explanation. Okay, it may have taken you more than one step before you finally got it all the way down to the greatest common factor. But when you did finally get it to the greatest common factor, you should have gotten to the point where you have an x and a 4yz. There's nothing else we can take out of these together. So our answer was 5x squared y squared times x plus 4yz. Okay, turn the page. And I want you to practice number 9, 10, and 11, removing the greatest common factor. Pause your video and then check back for the answers. Okay, so just checking your answers and making sure you got everything right. The biggest key is to make sure that you went enough levels to get out the greatest common factor so that whatever's left in the parenthesis is just a prime factor. So now we're going to put our two steps together and we are going to start solving equations. So we've got 3 steps that we have to follow. First, we have to make sure our equation is set equal to 0. Then we're going to factor out the greatest common factor. And then finally, we're going to take our factored form and set each factor equal to 0 to solve it. So on number 12, I can look in step 1, it's equal to 0. So I need to take out my greatest common factor using my area model here. Then I will set my 2 factors equal to 0 and solve the equation. So I would like you to do number 12 and number 13 on your own following these steps. Pause the video while you're working and then check back to check on your answers. So as long as you took it pretty much one step at a time, first you found your area model and removed your greatest common factor. Then you set each factor equal to 0 and came out with your answers. Now on number 14 and number 15, we still have to do step 1. So the only difference in 12 and 13 and 14 and 15 is 14 and 15 are not yet equal to 0. So before you can do anything else, you're going to have to get it equal to 0. And the way to get this equal to 0 is we're going to have to zero out the right-hand side. So what would I have to do? What would I have to add to negative 72x to make it 0? Well, I would add the opposite, so plus 72x. And I'm going to have to do that on both sides. So my new equation is going to be 6x squared plus 72x equals 0. And then from here, I'm ready to follow the rest of the steps. So I want you to factor number 14 and number 15 and then solve them. Pause your video while you're doing it and then check back for the explanation. So looking at your answers, you should have been able to get x equals 0 and x equals negative 12. And on number 15, s equals 0 and s equals 2. Now on number 15, I moved my 22s to the right side. A lot of you've probably moved your 11s squared to the left side. If you did that, that's just fine. When you were solving, you would have had 2 minus s as your factor instead of s minus 2. And when you did 2 minus s, you just had to remember to divide by the negative 1, and you should have come out with the exact same answer. Okay, the very last problem is our real-life application problem. Okay, so I want you to read this problem. It's already given you the equation, and it's asking you to set it equal to 0, so you're just going to be doing the same steps and process that you have been doing. So pause your video, work through number 16, then turn back on the video for the final explanation. So I set my equation equal to 0, found my greatest common factor, and once I set each factor equal to 0, I came out with x equals 0 and x equals 5.